A machine makes taps and valves. Each tap requires the work of 2 skilled and 5 unskilled workers per day and gives a profit of $3. Each valve requires the work of 3 skilled and 3 unskilled workers per day and gives a profit of $2.40. If there are 16 skilled workers and 26 unskilled workers available, find the number of taps and valves that should be made each day to maximize the profit. So clearly the different types of workers are the constraint, and we're making taps and valves. So if we let T be the number of taps that we make and let V be the number of valves that we make, then we know that T has to be greater than or equal to 0, V has to be greater than or equal to 0, non-negativity, you can't make negative numbers of things. And if we look at the tap, it's going to require 2 skilled and 5 unskilled workers, and the valve 3 skilled and 3 unskilled workers. So if we consider the skilled workers, every tap is going to require 2 of those. Every valve is going to require 3 of those. And we only have 16 of those, so that has to be less than or equal to 16. If we now look at the unskilled workers, every tap requires 5, every valve requires 3, and we have 26 of those. We may as well write down the profit function at this stage as well, so we'll write that down. So for a tap we get $3, and for a valve we get $2.40. So the boundary line here is 2t plus 3v is 16. If v is 0, t is 8, so that's just going to be here. If t is 0, v is going to be 5 and 1/3. So that's just here. Can't do it accurately on this graph. And that's going to look like that. So this one was 2t plus 3v is 16. Now, 5t plus 3v is 26. So, if v is equal to 0, t would be 5.2. If t equals 0, then v would be 8 2/3. So that's going to look like that. Well, this is 5t plus 3v is 26. And we're going to need to be this side of both of those. And so our feasible region is the region down here. Now, a problem is that apart from 0, 0, none of the other vertices are integer valued, and we can't make fractions of taps and valves. This one here we know is at 0, and it was 5 1/3, I believe. And this one here is at 5.20. And for this one here, we'll never be able to read that from a graph. So what we could do is get the calculator and solve some simultaneous equations. So we need to solve 5t plus 3v is 26 and 2t plus 3v is 16. And if we do that, we find that this one is at 3.33 and 3.111, and I think these are actually recurring decimals here. But once again, we can't actually make fractional amounts of these things. So what we need to do is look at integer valued coordinates which are close to the vertices. For example, just here, we'd look at 0, 5. So remember, the profit here was 3t plus 2.4v, which we can see just here. Now I'm not going to include 0, 0 in these list of vertices, but we really ought to if we're doing an actual exam problem, but never mind. Let's just look at the other ones. So 0, 5 we already discussed up here, and then we want some other nearby ones, such as 1, 4, for example. And other ones we can identify by going across are things like 2, 4 and 3, 3 and 4, 2 and 5, 0. Oh, I've got a blank on the table. I might as well put 0, 0 in there. We know it's going to be 0. So 0, 5. So 3 times 0, 2.4 times 5. That gives us $12 exactly. Then this one here gives us $12.60. This one here is $15.60. This one is $16.20, $16.80, and $15 exactly. So this one is the best. So we can get a profit of $16.80, and this corresponds to making 4 taps and 2 valves. And we're now in a position to do exercise 2e on page 65 of the 3D book.